We'll try to keep this lighthearted. So it's the afternoon. So whenever I think about that topic, DNS, TLS, and bad configs, I have this picture in my head. You know, in Harry Potter, when McGonagall says to Harry, Hermione, and Ron, like, why is it always the three of you when something happens? And it's pretty much what is still happening in everyday's world, right? It's one of these three things that tend to go wrong at some point. So to kick this off, I thought, let's take a look at three recent or well-known or common examples of how things go wrong. Let's take a look at how DNS can go wrong. So for example, I picked up a case from Akamai where lots of stuff went offline on their site just because they got DNS wrong, which is kind of the classic. I have my own story for this. This was luckily a long time ago at a previous company when I was migrating DNS servers, I think from Gandhi to AWS or something like that. And I was copy-pasting the DNS servers, and different domains had different DNS servers, and I was copying the same information or the wrong information. And then if you have the wrong root name server, which expired after 24 hours, at first everything looked fine, and then after 24 hours we could basically watch stuff disappear from the internet one step at a time. And since it has a 24-hour TTL, we could only watch as stuff kept disappearing in horror. Luckily, it was over the weekend, and it was the external DNS name I got right, only the internal ones that we were using, the servers I got wrong, and then we could kind of like patch that up with hosts files and everything. So it was quite a bad weekend, and we only found out when we looked at it ourselves and saw something is not working and something is not right. And that's one of the reasons why I think that health checks could help you out there, especially if you're not Akamai, who will probably see that on Twitter very quickly that something is wrong, that health checks can help you to figure out what is going wrong. We'll see a bit more in the why and how in a bit. Next up, TLS, and why TLS can also be one of the horrible things out there. So Microsoft is kind of a repeat offender. This was kind of, I think, a while ago, but they had some TLS certificate that they thought that they didn't need anymore, and they deleted it, and turns out they needed it somewhere still, and then everything went offline. There was a more recent case as well, but also that's still quite a while ago when SSL expired, which is kind of like the classic, and everything Azure went dark for some time, which is, again, in hindsight, it's always a very stupid problem because everybody knows that the TLS certificates are expiring and that you should rotate them in due time, yet we often still forget to do that. And then bad configurations are also the thing that kind of keep kicking us. Who remembers that big Facebook outage a year ago? And it was Facebook, Instagram, WhatsApp, whatever. Everything went out. And it kind of like, it was DNS on the outside, but it was a configuration or misconfiguration thing on the inside when they were doing some checks, and then they wouldn't announce some routes in BGP if something was not responding in the right time. And that took down everything. And I think everything, allegedly, it was so much that even their internal systems to unlock a door was built on DNS and the configuration, so they couldn't even enter the server rooms. And the story that is being told online, at least, is that they had to use a chainsaw or something like that to get through the doors to the actual servers to reconfigure them and fix that problem. So bad configurations can kick you in various places. Since Cloudflare was posting that, Cloudflare recently also had an interesting outage, which is double ironic because they wanted to fix some long-running project to increase resiliency, or they wanted to improve their resiliency, and that's what took out their service to a large degree. So it's oftentimes these things where you want to make something better and then add more complexity that will bite you at some point later on. And you could quite nicely see that in their traffic, that you change something and then the change actually hits like what the spine is, what they call like their busiest servers, and then you can see the traffic drop to half or whatever, and then they figured it out, they roll it back, and then it kind of like climbs back up. But it's like a classic outage problem where it takes you some time to figure out why is something going wrong and how can you fix that. So These are, I feel like, kind of like the horcruxes of IT that you have. DNS, TLS, and bad configurations. These are the things that keep haunting you and that will take your systems down sooner or later. So, how do you fight the horcrux? Yeah, you kind of kill them or take them out. And while I don't have like that venomous tooth to actually stab the book or whatever, like we cannot really stab our horcruxes, we'll need to find some slightly better approach. So my approach to horcrux killing will be health checks to figure out like something is wrong, hopefully before your users are shouting. I think there is this old story that Microsoft doesn't do that because they just let their users figure it out, and that's kind of like the cheapest way to, in terms of health check, but that might be another story. So, to structure your health checks and how to make sense of that, my kind of mental model is that you could ping from the outside of the network to see kind of like more closer to the user what is happening from their perspective. You could ping on the inside of your own network to see what is available there, or maybe like figure out the bad firewall misconfiguration, for example. And you could even ping on the host itself. So what could that look like? So, for example, to make this more concrete, let's say we have a service that is running on AWS, and you have whatever is happening internally here, but you want to have an outside health check, for example, from DigitalOcean. And that health check is just pinging, like, let's say, you have an endpoint that is called /status on your service, and that is responding and tells you what is working and what isn't working in your service. And with that health check, from pinging DigitalOcean to AWS, you can already tell, like, can I, from an external DNS server, can I do that DNS lookup and do I reach the right service? Is the uplink from AWS still working? Like, is the network reachable from the outside? Did I configure the firewall correctly somewhere on the outside of my AWS infrastructure? Like, is that actually reachable or not? Can I reach the load balancers and they are correctly forwarding the traffic inside AWS? Is the service generally available? And then the latency. And the latency is something that I will repeat in all three layers, basically, so that you could compare the latency also and see, like, where is latency being added or why is the latency so high in something? So that's kind of like the closer to the user almost. It's like the look from the outside, where you touch on the different services or different things that you can see from the outside or to figure out what might be broken here. Next up, come on. No? Next up, on the network, let's say we have our stuff running here, maybe in one or two availability zones, whatever. But I'm running my health check in like one of the other availability zones just to ping the application. And then I can check, like, is the cross-availability zone network, is that working within the data center at least? Did I configure the firewall correctly that something is maybe not reachable from the outside, but at least within the network? Is TLS still valid? We could do TLS from the very outside as well, but it doesn't really matter, so I put the TLS check here, like, are the certificates still valid and not expiring? Is the service available, and like, how is the latency compared to pinging from an outside network? Like, is the uplink slow, or what could you reach here? And then, we could even ping or also ping on the instance. So this is the instance that is running our application. And then we could do something like pinging external dependencies, like a database. So for example, to see, is the database up or down? Or maybe did you misconfigure the firewall on the database so that database is not available or reachable from your service? And all of those will give you very specific signals of what is down and what is up. And depending on which health checks fail, you could get a very quick look at, like, okay, my service is down, but my service is down because my service cannot actually reach the database, and that's why everything doesn't work. And then you have a much better picture of where to start looking and what to debug. You can also check in terms of health checks that the service is available from the instance itself. If you use something like a proxy, like let's say you have a Java application and you use an Nginx proxy in front of it to do TLS termination and then hand over the traffic. If only the proxy is down and you ping on the instance itself, you could ping both the Java application to see if that is available and the Nginx proxy to see if only the Nginx proxy is going away. that that is not reachable. And again, you can ping or check the latency to see is the slowness like from the start in your service, or is it being added somewhere on the way there? For example, is the outside load balancer something that is slow right now that is adding latency? Or is your reverse proxy, if you're running one, slow? Just all of these different layers, it's kind of like the onions of your network where you can check, where you can see where is something failing to pinpoint that failure more easily, but also to see where is latency actually coming from. So that's the idea from these different checks. So why am I talking about that? Obviously, we have something that does health checks. That's why I keep thinking about those a bit. And I wanted to give you a very coarse-grained overview for some of the ideas to implement them in practice for health checks. So, for example, here I have something that is pinging 32 services. 4 of those are down, 28 are up, and then I can figure out, like, are these relevant or not, or have they been failing before, and why? Also, to see some health checks easily that are going on here. So I'm doing an ICMP ping. I'm always using for my demos Xera WTF because that's the right domain for any demo. And I'm using the cron syntax to ping my server here through ICMP just to see if the server is reachable. How frequently am I pinging here? Who still remembers cron? Who has gray hair? Every 5 seconds. So every 5 seconds, we are pinging the host through TCP here. Then I'm doing a TCP check, for example, against MySQL and Postgres. Since they don't have an HTTP interface, I cannot actually check that, but I need to rely on a TCP. So for example, if I had a database, Xera WTF on these 2 ports, I could ping those every 5 seconds, and maybe this is the more readable syntax, but we do support both depending on what you prefer. And we could ping those ports every 5 seconds on TCP just to see is the database reachable or not. So for example, if the database dies, if you deploy a bad firewall rule, you would immediately see this rule fails, and then you could pinpoint and figure out that this is where you need to start looking why something is not working. And then I could say HTTP at, I don't know, my /status interface or endpoint on my service. I ping that through HTTP every 5 seconds again just to see if that is up or not. You could make this a bit more elaborate then, and with HTTPS, for example, check what is the certificate, by who was it issued, and how long do I still have until I need to rotate those. And these basically come for free with the HTTP checks as well. You can also make that a bit more complicated. So for example, if you want to actually check server processing, you could have an endpoint that is add, and then you do a post method, and then you say, okay, this is the header, and this is the body that I'm submitting, and then I'm expecting a 200 response. And it also says in the body afterwards, saved or saved. So one of these 2 needs to be returned, and only then will I consider the service to be workable. And this could be a bit more like an end-to-end check that involves, for example, a database just to see the service is not just running, but it can talk to the database, and the credentials are correct, and it's kind of like doing the right thing. Obviously, you will want to have something in here that you can figure out that this is just a pinger that will create a lot of data, and not something that is a real user. Otherwise, your stats might be off, or you might create a lot of trash in your data store. So something like that would also be possible, that you actually ping your service more or less frequently, but on a higher level, just to see like how much is working there. And finally, synthetic monitoring. Is anybody already using synthetic monitoring? 1, 2, very few, okay. So for those who are not aware, synthetic monitoring is kind of like you're simulating a browser. So you're normally running a headless browser, and then you're simulating a flow. For example, if you have an e-commerce shop, it would be like the most common thing that people are trying to do on your e-commerce shop. So for example, is you put something in that basket, and then you go to the checkout page, and then you do like a dummy checkout or whatever. The idea of a synthetic monitoring is that it continuously runs through your application so that you can figure out that something is wrong before your users are actually affected. So if that runs every minute and you deploy, and it just runs after the deployment and then fails, you know, I changed something in the most important flow of my website, I will need to look at that urgently before it actually affects any users. So synthetic monitoring is kind of the way to go there. Sometimes I have discussions with old people who said like, well, we've been doing this forever, we just didn't give it such a fancy name. But synthetic monitoring is kind of like the new thing under which you will find that. And what this is often using is Playwright under the hood, which is like the library framework, how you write those. So what Playwright actually looks like is we have wrapped Playwright, but Playwright is used by a lot of other synthetic monitors as well. So this will look very similar to what you have in other places. So what I'm doing is I'm opening up my WTF page, and then I say I wait until the page is loaded, and then I check if those placeholders are there, and then I expect a specific placeholder value if that is on the page. So that is a very simple step, but with that you could simulate pretty much any kind of interaction. Like you click something, something opens, you put something into a basket, you go to the next page to simulate the checkout. You can fully simulate what the user is doing. Who enjoys writing such code? Oh, I see 2 people raise their hand. I always call it the Stockholm syndrome. You get so used to doing that you start liking it at some point, which I'm not sure. You can also generate that. Playwright has a code generation where you basically open that page and then you can just click around and it will record what you have done, which might be the much quicker starting point. So you do your clicking around, and then you can manually edit the code that is being generated from the workflow that you have done, so you can clean it up, add the right checks, but you don't have to write every single command by hand. So that might make your life a little easier. So, since we have some more time left, or are there any questions so far? Because otherwise, I did set up a very quick demo on this. So let's see, I just did that like 5 minutes before. So for example, I have added multiple checks, and right now most of them are down because, for example, ICMP is not allowed on my host. I would need to add the right firewall rule, but I can, for example, easily see that I cannot reach the host and then figure that out why. The other thing that I've been mentioning about these layers, like the onion, there are a lot of tags that I could apply to this, and you can then either add the tag of the layer, or you could just say, this is, for example, a data store. And for example, I can see here that my data store is reachable from the instance of where I'm running it, and it also tells me that the TLS certificate is only expiring in 3 months. And with that, you could, for example, open this one up here and see pings over time, which were healthy or not healthy. You can also see the response times in seconds. And you can see from where was I pinging and how long did each one of those take. You could see kind of like the full response in those here. So this gives you a much better overview of like how is this specific service behaving. You could have multiple pinging locations to see how is latency behaving between those. And you could also get this overview of how is my TLS certificate behaving. So for example, you can see this certificate is only 8 days old, and it will then be fine for the next 3 months for running. But like that, you can easily pinpoint where to start fixing things early on. And then you can just, for example, I could filter down just on this tag for data stores. Are my data stores reachable? Is DNS working? Did I misconfigure a proxy? With that information, you can very easily figure out like where is something falling apart and where do you need to start looking. Obviously, this is only an addition to what you're trying to do in observability, where you have the insight from the inside. This is really the classic monitoring look from the outside, where you try to look at things that have been failing in the past, but it can still be a very fast and also cheap signal to figure out what is going on. Because this data is there's not a lot of data to store, And you can also expire it very quickly, because the health checks after 24 hours potentially, if you want to compare latencies, maybe a bit more, but otherwise you don't really need to keep that for comparison very long. So it is pretty cheap to run and just get a quick overview of what is happening. Whereas tracing will have 100x the overhead in terms of data you need to store, whereas health checks are very quick and cheap, and while they still add a lot of value to your service. Any questions for that so far? Otherwise, let's see what we have here. So health checks, like I said, they're cheap, they're fast, and they give you an overview. And they are definitely only an addition to observability, because everybody just wants to talk about observability. I wanted to kind of like come back to that old monitoring thing that we have been doing before, but I feel like it's getting very little attention in the last few years, because everybody wants to move kind of like to the inside of the application from observability's point of view, and very few look at what can I still get out of my application from the outside. You can start simple. Synthetics are, of course, a lot heavier also in terms of instances when you need to run them, and they're a bit more error prone. So I think they're a good addition if you're at the right state. If you have an application that is constantly changing in the UI, your synthetic monitoring will be a hard battle to keep up to date and current and not break with every UI change that you apply. So once you have found a stable place for your application, I think synthetics can add value. It doesn't mean that they will be the right starting point necessarily. I think classic health checks will get you very far to see what is going on. And that's it.